This is the intro video for AP Calculus BC, section 5.1. You can see here in chapter 5 we're going to be talking about transcendental functions. Transcendental functions are functions like e to the x, ln of x, arctangent, tangent, sine, inverse cosine, things like that. And you can see today here we're going to be looking at the natural log function. We're actually going to be looking at that for a couple of sections here. And so let's just take a brief moment and let's talk a little bit about what ln actually is. Let's remember a couple things, that ln is really log base e. And you've used ln probably quite a few times in your pre-calculus classes, but we're actually going to give a definition for it right here. Ln of x is equal to the integral from 1 to x of 1 over t dt, as long as x is positive. So for just sort of an informal proof of this, I thought we'd use your calculator to try to illustrate this. So I'm going to flip over to a calculator screen here. You feel free to do the same. And here's what we're going to do. We'll do something really simple like ln of 3. And we get an answer for that. And then we're going to do that little formula that ln is supposed to equal. So we'd go integral from 1 to 3 of 1 over t dt. Of course, your calculator, the most convenient thing would be x here. We could switch it over to a t, I guess, if we wanted to, but we can go with this, no problem. We hit enter, and you can see, of course, that it's the same. So far from an ironclad academic proof of this, but hopefully that's maybe some proof for you that that relationship is actually true. So let's go back over to this screen and let's talk then about what the derivative of ln of x would have to be. So if ln of x really equals the integral from 1 to x of 1 over t dt, then the derivative of ln of x would equal this, d dx of the integral from 1 to x of 1 over t dt. Right? We're just differentiating both sides. So hopefully you recognize on the right side that we have FTC2 happening, and so with that we will recognize that the derivative and the integral will cancel each other out, and the x simply drops in where the t is. We get 1 over x. Technically we multiply by the derivative of what we dropped in, so it'd be times 1. I'm not going to bother to write that right now. And so yeah, the derivative of ln of x is 1 over x. If you do have a composite function, that's where the chain rule probably will apply a little more readily, a little more obviously. So this would be interpreted as d dx of the integral from 1 to u of 1 over t dt. And so again, you know, the FTC2 applies. The chain rule will show up here though. We're going to get 1 over u times du dx. We also could see it written as 1 over u times u prime, and the more familiar notation that we've seen a lot would be u prime over u. So these are derivatives of ln of x or ln of u. Really the only difference is the input going to be a composite or not. So we're going to do one example here. Example number 1 down here at the bottom is d dx of ln of 5x squared plus x. Of course, we want to recognize that we're doing the derivative of ln, so the derivative of ln is going to equal 1 over whatever the input is, so 1 over 5x squared plus x times the derivative of that inside. So that would be times 10x plus 1. Of course, this could be rewritten to be 10x plus 1 over 5x squared plus x. So that's it for this video. Hope that was helpful to you. See you next time in class.